I start with introduction and the general data protection regulations. And as you all probably know, there are lots of health data around which are valuable and could be used for our research. But the problem is that we have a lack of data protection compliant infrastructure to share, to store, and also to process such type of data. And a particular challenge is that data like, for example, brain data, radiologic images of the brains contain information that is individual. Yeah. So even if you would remove primary identifying information like the name, the address, the birth date, you would still have information like a fingerprint that enables re-identification of the subject and the data. And we do not want to remove this information because this is the relevant information for personalized health research. So we cannot really anonymize the data and not even pseudonymize the data, as you will learn later. And it has been shown that the data, such as connectome data, functional connectivity, structural connectivity, can be used to learn a lot about the personality of the individuals, the data subjects. So for example, in the study, here you see in color code the fluid intelligence of each individual subject, and it has been shown that the fluid intelligence correlates with features of the connectivity. And here on the right, you see many more aspects of a personality, for example, the use of cannabis, alcohol problems. Here on the negative side, this is a positive negative axis. And here on the positive side, the ability to sustain attention, for example, or to delay reward, and many other positive things. So based on just the information and the pictures of the brain, there can be made inferences about the personality, and even worse, given the data that are available, like genome data, for example, in combination with other data sources, for example, family trees that are also freely available in the US, for example, in the internet, you can easily re-establish the identity of a person. This has been nicely shown, for example, in the science publication. So in roughly 1,000 individuals in the study, 12% of the individuals of whom the genetic data and the family trees were publicly available in the US. For 12% of these people, the identity could be clearly re-established. And the General Data Protection Regulation is a law that came in force in 2018, so just 3 years ago, that wants to protect the people in the European Union from abuse of their personal data. And there are 7 main principles of the General Data Protection Regulations. They are listed here: lawfulness, fairness, and transparency, purpose limitation, data minimization, accuracy, storage limitation, integrity and confidentiality, and accountability. There are also clearly defined roles for the people who are involved in personal data processing. There's the data subject, that is the person to whom the personal data belong. Then the data controller, this is a person who determines the purpose of the processing of the data. And there's a processor on behalf, or processor, that is a person that processes the data on behalf of the data controller. The person does not determine the purpose of the processing themselves. And the role as a data controller, this is mostly the role of a researcher, a scientist, a PI, comes with obligations. And these obligations are also written down in GDPR. There's, for example, Article 25 that regulates data protection by design and by default. And it states, for example, that the data controller shall implement measures such as pseudonymization to protect the rights of the data subject. And very importantly, such measures shall ensure that by default personal data are not made accessible without the individual's intervention to an indefinite number of natural persons. Yeah? So in the EU, it is not allowed to, even if there's a consent for using the data, to share personal data with an indefinite number of people. So you cannot put such data on open repositories, for example. Article 32 GDPR regulates the security of processing and provides more details, for example, the need for encryption to protect the data. And it also states that taking into account the risk related to accidental and unlawful destruction, alteration, unauthorized disclosure of or access to personal data, or otherwise. So unfortunately, I cannot read the text because it's covered. I try to remove your helps carefully. Sometimes it breaks the sharing, but it worked. Data transmitted, stored, or otherwise processed. So when considering the measures that are needed to protect the data controller also has to take into account the risks for the data subjects. No, I don't see the header. Okay, so it's the personal data definition in Article 4. It states, just see whether I can, there's always part of my slide covered. Now I try to put it on the other monitor. Okay, this is better now. Personal data means any information relating to an identified or identifiable natural person, data subject. An identifiable natural person is one who can be identified directly or indirectly, in particular by reference to an identifier such as a name, an identification number, location data, an online identifier, or one or more factors specific to the physical, physiological, genetic, mental, economic, cultural, or social identity of that natural person. So now we come to pseudonymization. There's often a misconception that when just removing the name and the address and the primary identifying information, this is what we call pseudonymization, but the GDPR clearly gives a definition in Article 4. Pseudonymization means the processing of personal data in such a manner that the personal data can no longer be attributed to a specific data subject without the use of additional information. Now, importantly, provided that such additional information is kept separately, number one, and number two, and is subject to technical and organizational measures to ensure that the personal data are not attributed to an identified or identifiable natural person. So in order to be regarded as pseudonymized data, the information that leads to re-identification needs to be subject to technical and organizational measures. Yeah? And the example that I have given you for the re-identification based on the online available genetic or family tree databases, this would not apply. So in this case, if there's such detailed individual information available in the data themselves that are not removed, we cannot label them as pseudonymized. Nevertheless, of course, we can remove also on those data primary identifying information like the name and the address, and also, for example, the face and radiologic images of the head. So this was the point I just have made for some data that are important, especially in the context of brain research and for EBRAINS, the Human Brain Project. We cannot or do not want to achieve anonymization because we want to do the research on the personal and identifying information. But we cannot even achieve pseudonymization because the identifying information that is still contained in the data is kind of fingerprint information that can be used for re-identification. So MRI or connectomes contain factors specific to the physical, physiological identity of the natural person. And even worse, brain data contain information about the health of an individual. And the GDPR says information about race, ethnic origin, sexual orientation, political views, religious beliefs, genes, biometrics, health, etc., are sensitive personal data. The processing of this kind of data is generally prohibited. Yeah, this is regulated in Article 9 GDPR. It's called processing of special categories of personal data. And here you can read that data concerning health, the processing is generally prohibited. There's an exception, one important exception is that an explicit consent for the processing for a specific purpose is provided by the data subject. There's another possibility listed in GDPR, namely that the processing is done for scientific research purposes. Given that, in addition, Article 89 applies, that says that sufficient security measures need to be in place to protect the data. So the combination of having sufficient security mechanisms in place, plus research purposes for processing, will enable a data controller to have a lawful basis for processing and do the processing of the data. GDPR also regulates the requirement for data protection impact assessment and prior consultation of data protection officers in Article 32. That is stated if you use, for example, new technologies, like, for example, EBRAINS or the health data cloud, and if there is a high risk, and there's always a high risk if health data, special category of data are being processed, then a data protection impact assessment is needed, and also data protection officer needs to be consulted. Also, in addition, data protection impact assessment is required according to Article 35 if there is processing on a large scale of special category, that is health data, according to Article 9. So now, what does a data protection impact assessment comprise? First of all, a systematic description of the envisioned processing activity, then also an assessment of the necessity and proportionality of the processing, an assessment of the risks to the rights and the freedoms of the data subject, and also the measures envisaged to address the risks, including safeguards, security measures, and so forth implemented. So for each individual processing step, if you want to process health data, we need to have an assessment of the general principles of GDPR, the data security measures in place, and an evaluation of the data subject rights. And this we will see in the next slide. What are the data subject rights, also regulated in the general data protection regulations? Number one, the right to information. Number two, right to object, right to withdrawal, right to correction. So when there's an error, erroneous information in the data, the data subject can ask for correction of the data. Right to erasure, then at any time point, the data subject can ask to delete data. Right to restrict processing. So the data subject can decide for which purposes the data are being processed and for which purposes not. And the right to data portability. So when they are in a platform in EBRAINS, the data subject can ask, for example, to receive the data and to port the data to another platform or even to their personal computer. How does a person or a researcher become a data controller? So at the moment when you are processing personal data, you automatically are the data controller. So it's not a formal act. It's not that you have to go in an agreement to become a data controller, but at the moment when you process or access personal data of others, you are a data controller. And with this, you have all the responsibilities that come with the role of the data controller according to GDPR. How will you become a lawful data controller? According to Article 6 GDPR, there are different possibilities, and one is that you have a consent that has been provided by the data subject for the specific purpose of processing the data. But the consent also has to be obtained under certain conditions to be valid. So the controller, first of all, needs to be able to demonstrate that there is a subject consent. So that's the obligation for the data controller to provide the proof of subject consent. The consent information, the information given to the data subject when signing the consent needs to be intelligible and easily accessible using clear and plain language. Then any infringements that are not compliance with GDPR are not binding. So for example, if the data subject signs that the data can be used and made available to an infinite number of individuals, this is not in line with GDPR, and therefore this is not binding. There's a right to withdraw the consent. We had this already. This is one of the fundamental subject rights, and the consent needs to be freely given. One of the subject rights is to withdraw consent, and therefore, of course, it is important that this is technically possible. So they have to be informed about the identity of the data controller. They also need to have the contact details of the data controller. Also, when applicable, the contact details of the relevant data protection officer. And they also need to be informed about the purpose of the processing of the data. In the context of EBRAINS, maybe so such large international projects are also relevant, that the data subjects have a right of being informed about to which countries data are being transferred, if that is the case. And there is so-called adequacy agreements with some countries where the data protection law is similar to EU law, and they're listed here. So, for example, Canada, but only in the context of commercial organizations. This is not the case for academic organizations, interestingly, has such an agreement. Many of the Channel Islands, Japan, but for example, not the US, and many other countries. So it's only a very small list of such countries. If you want to transfer the data in other countries, like the US, for example, it's getting more complicated, because then as a data controller, you have to document that there are appropriate safeguards for the protection of the data in place, and even more difficult to achieve, that there are enforceable data subject rights and effective legal remedies for the data subjects. Yeah. So if there's if there comes a situation that the data privacy rights of the data subjects are hurt, then there need to be also the legal apparatus so that they can get the remedies for this case. So now if a researcher plans to process personal health data, several steps are required. First of all, the data subject information needs to be prepared, and also the consent forms. There are pre-existing templates, and we, as the leaders of the virtual research environment, also provide such templates on our website. Also, the goal of the Health Data Cloud is to provide such forms to facilitate the conclusion of agreements with data subjects and also with other data controllers. Then a data protection concept is needed, vote by the relevant ethics board. So it also requires an ethics application, of course. The relevant data protection officer needs to be consulted. And also for this, application forms are available. And then in the case of health data processing impact assessment needs to be prepared. So now in a very typical or common case, if we want to share MRI data, for example, So you have acquired MRI data or a data controller for MRI data. What would be required from you in order to share those data with another person, for example, via a sharing platform, a repository? Then first of all, you need to establish a lawful basis. So it's the responsibility of the present data controller to establish the lawful basis for processing of this data by another person before sharing the data. If this is established, then the data can be shared. And in this context of relevance is the repurposing of data. So usually if a data subject provides a consent, then according to GDPR, the consent needs to be for a specific purpose. And now the question is, if the purpose is a specific research question, can the data repurpose for another research question? This is also addressed in GDPR. So in principle, this is possible if the new research purpose is compatible with the purpose for which the personal data are initially collected. Or I should actually not say research purpose if the new purpose is compatible with the purpose for which the personal data are initially collected. Some how be evaluated, taking into account the context of the agreement, the consent concluded with the subject. Interestingly, according to Article 5, it is not similar, but I think it's Article 5, for scientific purposes, the consent may not be considered to be compatible with the initial purpose. So basically, according to Article 5, for scientific purposes, a repurposing of a consent is always possible in combination with Article 89, which we had before. So if given that the appropriate safeguards, given the risks are in place. So then another maybe important article in GDPR, Article 28, regulates the responsibility of a data processor. So we have now talked a lot about the role of the data controller, but data processors could be, for example, students who would process the data on behalf of the PI, who determines the purpose of the processing. But a processor could be also a platform, a service provider that processes the data on behalf of the data controller. And in such cases, there needs to be a contract for data processing in place. The service provider or the processor shall adhere to the instructions of the controller. The processor or service provider implements adequate technical and organizational security measures. Service provider or processor binds its staff to confidentiality. The service provider or processor does not engage any other sub-processors without authorization of the data controller, and makes available all information to the controller to demonstrate the compliance with GDPR. Yeah, so if a platform is offered for processing on behalf to the data controllers, researchers, then there's an obligation of the service provider to provide the controller with all the information that demonstrates the compliance with GDPR. Then this slide is to deal with a very common misconception that data who are owned people, personal data are never owned by even the data subject. The personal data are exclusively regulated by GDPR and not by proprietary law. So the data controllers are not the data owners, they only act as stewards of the data. So this was the crash course I wanted to give you for GDPR. All these laws and rules are relevant and yeah, need to be understood and known before we can then talk about secure and GDPR compliant infrastructure and platforms. And this is a topic in our session today. So the heading of our session is the Health Data Cloud, and the Health Data Cloud is actually a project that has not been started yet. It's a project that has been selected as a winning project in the call for services for sensitive data by the HPP and EBRAINS. The partners are listed here. The coordinator is the Charitè, and there are altogether 9 partners, several of which are compute centers. INDOC is a partner of the Charitè, who has established the virtual research environment at the Charitè that I will show you in a moment. The other partners you will recognize are established HPP or EBRAINS partners like the CCS Jülich Supercomputing Center, Barcelona Supercomputing Center, also KTH, and Oslo University Hospital, that itself has already in place a GDPR compliant IT infrastructure, and Athena, the technical coordination team of the HPP, and as a new partner, the ETH IT department that also, I think, has in place their own GDPR compliant environment already. The goal of the project EBRAINS Health Data Cloud is to build on an existing architecture of the virtual research environment that sits at the Charitè in Berlin, and build an architecture and governance processes for EBRAINS to deliver services for sensitive data, to enable collaborative collection, sharing, analysis of sensitive neuroscience data from human subjects. And this is a general high-level illustration of the architecture. So I mentioned the virtual research environment, which is a GDPR-compliant infrastructure that sits at the Charitè. That will be one satellite node of the Health Data Cloud. There's a plan to have a similar, if not identical, architecture established in the EBRAINS central node, and then having a list of satellite nodes that can comprise the full functional scope or only parts of the functions that are available now with the virtual research environment. This could be, for example, the Oslo University Hospital, where the goal would be to make it interoperable with the other nodes and the central nodes, so that the information about the data stored in the satellite node can be retrieved from the central node via the knowledge graph. The functionality, as I mentioned, of the satellite nodes may differ. Some might be just data repositories, others might contribute HPC resources, and others might contribute a combination of both. This is a minimum architecture of the virtual research environment with the web portal component, a green room zone, which I will explain in a moment, the core zone and the workbench zone. And this is the basic functionality or range of components that will be, or services that will be available at the different nodes of the Health Data Cloud. This is the portal of the existing virtual research environment that provides the basic architecture of the future EBRAINS Health Data Cloud. And you find this under the URL vre.charitè.de. This is a basic architecture. You will get much more detailed information later in the following presentations, especially in the last one of this session, provided by the INDOC research team and by Patrick from the Charitè. The one component of the VRE is the research portal that provides researcher-facing functionality and also functionality for the system administrators. A very important component is the green room, that is a restricted, particularly secure zone where data land when they still may contain primary identifying information. So this will be the area where primary identifying information is removed, like name, address, birth date, faces. So there are also automated workflows in place, for example, for defacing radiologic images to remove as much as possible from the identifying information in the data. The data then go in the core zone that contains the bulk of functionalities, including a data catalog, project-specific data warehouses, knowledge graph functionality, metadata repositories. and all the possibilities for analyzing the data, deploying different tools and services for manipulating and processing the data. So there's a possibility to use virtual machines, so similar to what we have here in EBRAINS, or using Jupyter notebooks to, for example, control processes that then may run either on virtual machines or on high-performance computing backends that are part of the GDPR compliant infrastructure. As I mentioned already, there's a possibility to bring in the researcher's own software or code to analyze the data. And this is just the underlying platform functionality to maintain the platform functionality. Here you can see that there are direct interfaces to various data sources. So there's an option to bring in data via programmatic interfaces through the portal, or also via graphical interfaces. But in the virtual research environment, there's also the possibility and the desire to directly channel in data from for example, hospital data sources like radiologic imaging PACS systems. Here at the Charitè, we have research into clinical PACS, or RedCap systems that are often used for the organization of research data. And these data can be directly ingested in the virtual research environment via dedicated pipelines. Importantly, the virtual research environment has undergone GDPR readiness audit by an external law firm. This was a long process of evaluation where all relevant stakeholders at the Charitè were involved, like the data protection officer or also the IT department. It has been established in this evaluation that the VRE...
Excuse me, Petra, one short question. What's the timing of this thing? Because you're currently some 9 minutes over the talk time. And I'm not sure how long the slots afterwards will be. So far in the agenda, they all have 25 minutes plus 5 minutes discussion. So
okay, so I had 30 minutes in total, right? So I will, yeah, I'm almost at the end, and maybe we can then have the discussion at the end, and I have no long discussion after my presentation.
Thank you.
Thank you very much for pointing this out. So you will see the details and the presentation by INDOC Research later. So I just roughly mention here that it has been established that the virtual research environment is in compliance with GDPR, in particular with Article 25, data protection by design and by default, and Article 32, security of processing. The details you will see later. There's also a network architecture in place that you will probably also see later, again with dedicated zones that provide restriction of flow of information as an additional security measure, and of course encryption and sandboxing mechanisms to ensure that the data are safe when they are stored, but also when they are decrypted, during the time when they are decrypted and being processed. There's a lot of documentation, thousands of pages of documentation available. A nice element is that there's a detailed wiki that is accessible via the VRE portal that provides a lot of information for the users and the data controllers, and also templates for concluding the necessary agreements. And I think this is probably my last slide that just shows you a high-level description of the health data cloud architecture. You will recognize some of the elements that we have already in EBRAINS, and several teams here in HPP and EBRAINS are working on, like the knowledge graph, the container pipelines, data-led for provenance tracking, standardized data structures like bits, and data models like OpenMinds. And an important component is then to also have workbenches that provide the secure environment to directly interact with the data.